Hello everyone. With this video, I'm starting a series of new tutorials on composing visual music. I am Michele Zaccagnini, and I'm a composer and multimedia artist, and I would like to share some of my research with these tutorials. With this video in particular, I want to just describe my approach to composing visual music, some general ideas, and then describe the tools that I'll be using, and then we'll go from there. My background is in composition, but I started using visuals several years ago. I'm interested in visualizing music for my own work to help me compose. And while a score is great for many reasons, with electronic music and in general with new tools of composition, we can actually represent music in many different ways. But also, once we visualize the musical data on a pseudo score, on some kind of visualization other than the traditional score, we can actually use those visualization to increase or add an extra layer of perception to our compositions. If we think of a soundtrack for a movie, the connection of images and music is pretty loose on a perceptual level, meaning they don't really connect in a very specific way. There are sync points sometimes, but the connection is usually on a more abstract level. So, say, describing the emotion that the scene is supposed to convey. So, this is what I call a high level connection. So, when visuals and sounds are loosely related. So, I'm more interested into the low level approach, which means that I won't be dealing with the abstract issues of musical narrative or structure, but rather on how to connect the musical event to a visual event in the simplest possible way, and in the way that is most perceivable on a low perceptual level. Um, so a way of practically implementing this approach is to really translate the musical data into a visual correspondent. If we think of musical categories as three simple categories, of course there could be more. Then pitch can be described as being high and low, or consonant and dissonant. Rhythm can be described as being dense or sparse, as being regular or irregular, and timbre can be rough or smooth. So we could translate, so there are many different approaches to this, and I guess this is what the composing visual music series, tutorial series is about, is how to translate the musical data into a robust visual representation. The object, if we think of musical events as objects, then the pitch could be translated in a position of the object. Rhythm could be translated into the kind of motion that the object has. And timbre can be translated, for instance, to the surface. So this is not all that there is to it, of course, and I will be exploring different approaches. Then I can jump onto uh, this patch. that contains a JS file, JavaScript file, that does a simple operation based um, on an algorithm described by the Wolfram Science website, and in particular by the book A New Kind of Science, which, as you can see, offers um, different kinds of ways of generating surfaces based on simple programs. And so an algorithm like this one will generate a surface that it's very smooth, and that I can increase the roughness by just operating on a single parameter. So I can translate this matrix that I'm generating here into sound, and as well as into a visual. I mean, it's already a visual, but I can actually use this to generate, for instance, a 3D surface with some kind of corrugation. And I have done that for instance, in this video. Two patterns are on top of one another, and the surface in this case is smooth. But if I go forward, and I can actually see how the surface gets okay. This is a quick example, and there will be more explaining how that's done. Tools that I will be using for this series of tutorials are Max, first and foremost, as the general environment where I will be drawing my algorithms. And then I will be using the Bach library, and I will be using JavaScript, and I will be using Spear as way of analyzing sound and take some information from it, and some algorithms from all over the place. One I just showed from the Wolfram Alpha website. So I will be talking about this in more detail in the future. Stay tuned. Thank you for watching.